Hi guys, we'll start very shortly. If you can hear me, just write a comment or something, and we'll start in 2 or 3 minutes. If you have any doubts, questions on the previous session or in general or anything that's going on, feel free to post right now and I can answer. Uh, and then we'll start around 10:05. So just 2 3 minutes from now. Thanks, Aditosh. Anything on the previous session? People who attended the previous one, did you revise the session? So one thing I have noticed is we did algebra and we did commercial arithmetic and we did it some time back, and now I am noticing people are asking questions based on concepts which were covered in those topics, even on topics which were covered in triangles. So it's, I keep repeating that, but I'll still say that revising is as important as studying new topics. If you have studied something but then you forget everything about it within 2 months, then when you study it for the next time, you will again be putting in all that effort. So it's very important that once you have studied something, you keep revising it after every 1 month or so, because otherwise all that work is wasted. So that's something to be wary of. Another thing, and I'll put a post also on this. We are almost finalized our on a YouTube channel. We are putting up all these videos in case somebody wants to refer them back. So there will be 14-15 videos just in one place, so that if you want to revise any topic, you can very quickly go through it. I think in terms of quality of videos, there are other which are better quality out there, but the advantage that you'll have with these sessions is that they're fairly brief. So if you revise only 2 or 3 hours of video, you will be able to cover most of, say, geometry, or 2 or 3 hours of video will cover most of algebra. So it might be a good thing for revising, not for studying for the first time, but revising. You, that channel might be very good, because I think within 20-25 hours we'll be able to cover the entire quant course. So I'll be putting the link for that later on. We just need to do some final cleaning up over there. So that is there. In terms of, I will start, I think, just in 1 or 2 minutes more. Today's agenda is I have a few difficult questions on circles. The plan was to do mostly difficult questions on circles, but then I felt that it's important to complete the course as soon as possible, and we will do difficult questions in the last 2 3 months. So I'll do some difficult questions on circles, and then we will cover polygons a bit. So we'll cover basics of polygons and do a few good questions on that. And then in next class, we'll cover quadrilaterals and mensuration and so on. And then after that, we come to PNC probability, which is the only part left. So I'll start now. So today we only have to do questions. We did a lot of theory last time. If some of you didn't attend, you can attend the video which is on the portal. So let's look at this question. Here what is given is there are two chords which intersect each other at P. So this is point P and they intersect over here. And we have been given three lengths. So we have been given length of PC, which is 12. We have been given length of PD, which is 2. And we've been given length of PB, which is 4. And we have to find the area of the circle. So how do we go about it? Some things should strike you straight away. We did this last time as a theorem. PC into PD when chords intersect will be equal to PB into PA. And we have the values of PC, PD and PB. So you can calculate PA very easily. And that will be 12 into 4 by 2. 12 into 2 by 4. And this becomes 6. So we get this length, which is 6. But we need to find the area of the circle, and for that we need to find the radius. So what can we do? We'll do what seems easily observable. Let's join these 2 points. So this is your radius. This is the center. So this becomes my radius. And then we had learned that if you draw a perpendicular on the chord, it will bisect the chord. So we make this perpendicular. So we have made this perpendicular here. So this should bisect the chord. The entire chord's length is 12 plus 2, 14. So what will be this length be? This length will be equal to 7. So this particular length is 7. We can use Pythagoras theorem in the triangle, but we need to know this length also. And this length also we do know, because this is also at 90 degree, it has been given. So this is 4, this is 6. So if we had drawn a perpendicular here, this would have been 90 and it would have split it into 2. So this chord's length is 10, out of which 4 is on this side. So till midpoint it would have been 5, out of which 4 is on the other side. So this length becomes 5 minus 4 equal to 1. So one side is 7, the other side is 1. You need to find the length of hypotenuse. That you can do very easily. R is equal to 7 square plus 1 square under root. You're asked to find area, and area would be pi r square. So you don't even need to find the under root. R square is 7 square plus 1 square, or 50. So area will be equal to 50 pi. Ritesh is commenting that he can't hear anything. Is it true for everybody else, or is it a problem on his side? Because I checked audio in the beginning and I thought I got a comment that people could hear. Okay, so maybe it's a problem on Ritesh's side. So uh, maybe if he could, he could probably not hear me. So I don't know. But is this question clear? So we haven't done anything out of the ordinary for the question. We have just combined two concepts which we studied last time. One was that if two chords intersect, then products of their segment is equal. The other was that if you drop a perpendicular from the center on a chord, it splits the chord into two parts. We used that to get the answer. Ideally, you should go home and try this yourself also, the same question, and then compare. Let's look at this question. We'll cover a concept which we haven't covered earlier on coordinate geometry. We haven't done a lot of coordinate geometry, but we'll cover this concept over here. So let's see. What we have been given is, if you know coordinate geometry, it's a pretty easy question, but we'll see. So there is a circle which has been drawn with radius 2. So this circle's radius is 2. And then there is a tangent on it, which at the point root 2. Okay, there's a tangent on it at point root 2, and we have to find this particular shaded area which is given here. So what is this area? So how will we do that? To get this area, what is very obvious is, if we know the area of the triangle, if we know area of triangle AOB, and then if we can subtract the area of the quarter circle, that will be the area, right? That will be this plus this side. This side will also get included. And then since the figure seems symmetrical, we can divide it by 2 and we'll get the area of one side. So how do we calculate that? Can we calculate the area of the quarter circle? Yes, because we know the radius, so we know that part, right? So this radius is 2. The area of the quarter circle will be pi into 2 square divided by 4, because this is 1/4 of the circle, which comes to pi. So the area of the quarter circle is pi. What is the area of the triangle? How do we find that? And there we need to use a bit of coordinate geometry. So in coordinate geometry, the slope of a perpendicular line, so this line will be perpendicular, right? So the slope of two perpendicular lines, the product of slope of two perpendicular lines, m1 into m2, is equal to -1. Okay. And if you don't know this, there are on the portal in the geometry basics section, there are videos which explain how slope is calculated and how this relationship is arrived at. So you can go through it. But for now, just believe this, that the product of slopes is -1. So using that, you can get the slope of this line. So that seems one approach, because I can get the slope of this particular line very easily. This is 0, 0. This is root 2. So the slope will be root 2 minus 0 by root 2 minus 0. And that will come to 1. So this line slope is 1. So the slope of the perpendicular line will be -1. So the slope of this line is equal to -1. So using that, we can get this equation also. So now we know the slope of AB is equal to -1. So we can get the equation of that line, which will be y minus root 2, because we know a point on that line. So y minus root 2 by x minus root 2 equal to minus 1. And you can simplify that and it will come to y plus x equal to 2 root 2. So we know the equation of this line, y plus x equal to 2 root 2. So we can get a and b both, and you put x equal to 0, you get the value of y. So this line is y plus x equal to 2 root 2. So the value of b here would be 0 comma 2 root 2. And this a will be 2 root 2 comma 0. We have just put x equal to 0 and y equal to 0 in them to get these intercepts. And now I know the length of both sides of the triangle. So this side is 2 root 2. The base is 2 root 2. So what will be the area of the triangle? Area of triangle will be half into base into height, and both are 2 root 2. So you can just do half 2 root 2 square. And that will give you 8 by 2, 4. So area of triangle is 4, area of the semicircle is pi. So the area of the shaded segments is 4 minus pi divided by 2, because the figure is symmetrical. So this area will be equal to this area, and we divided by 2 to use that. Is it clear? I did a lot of stuff, but most of it is simple, especially if you know a bit of coordinate geometry. Not a lot, even a bit is sufficient. So hopefully it should not be very complicated. If it is very complicated, let me know and I'll make changes or explain a bit more. I'll just erase it a bit so it's clearer. What we did was fairly simple. We had this line, we had a point on the line. We decided if we can get the slope of the line, we can write its equation, and then we'll be able to get these 2 points. To get the slope, we knew the slope of a perpendicular line. So we used that to get this line slope, and then calculated the x and y intercept. And using that, we calculated the area of the triangle. Okay. It should not be difficult. If you are finding it is difficult, let me know. And basically it means you need to practice a bit more of coordinate geometry, that's all. But if you find it difficult, then it is a signal that the level that you need to have is not there in that particular topic. Let's move on. So now we have a question here. There is a triangle, right angle triangle. So this is A, this is B, this is C, and there is a right angle triangle, and it is at 90 degree at angle C. So this angle is 90 degree. And then we drop a perpendicular on the hypotenuse. So AD is a perpendicular, and that perpendicular, there is a incircle created on both sides. So there is this incircle and there is this incircle for both these triangles. We need to find the length PQ. What would this length be? So we have seen this kind of a situation before. When we were doing triangles, we saw this kind of a situation, that there will be a perpendicular on the hypotenuse from the side which has 90 degree. And we had learned that just by equating areas also I can calculate the distance of CD. So let's see if I can get CD here. That seems to be one way to approach. So we'll try that. There is this side which is length is given 15. This side's length is given as 20. So the length of hypotenuse would be 25. Now if you want to equate the area of triangle ABC, area of triangle ABC will be half into 15 into 20. But it will also be equal to half into 25, which is the hypotenuse, into the perpendicular on the hypotenuse, which is CD. So using this, you can calculate that CD is equal to 20 into 15 by 25, or what does it come to? 12. So CD's length is 12. This side's length is 12. What can we do to get the in circle. We need to know this radius. So we know that this is R1, this is R2. R1 plus R2 is the answer we are looking for. So we are looking for R1 plus R2. If I can get AD, if I can get this value, if I get this value, this is X, this is 25 minus X. If I can get this value, then I can do something, right? Because then I will have the sides of both these triangles. And we also did a formula earlier that area of a triangle is R into S. So we get in radius from there. We get area of a triangle as R into S. And we also know the area of a triangle because it's right angled. So it will be half into 12 into X for the smaller triangle, or half into 12 into 25 minus X for the bigger triangle. So that seems to be an approach. If we can get somehow the value of AD. Now how can we get AD? One way is you can try using relationship of tangents, which we did in the previous session, and which is very appealing here also. You can see, you know that length of this tangent will be equal to length of this tangent, or length of these three tangents will be equal, and you can use that to get the lengths also. But that would be much painful and a longer process. What would be easier to do is something which we again did in the triangle session. So that's why I say that you have to revise easy questions very well, because difficult questions will use concepts which were there in easy questions. And if you like really have it at the back of your head, it will strike you quickly. So here triangle ADC, this one, this triangle, and the triangle on the other side, BDC, this triangle, both are similar. You should know this, or even if you don't know this, now that I've said it, you should very easily be able to see that. ADC, there is this angle is right angle, this angle is, so this plus this is equal to 90, and for them this plus this is equal to 90. And we also know that A plus B equal to 90 because the bigger triangle is a right angle triangle as well. So you can you think through this, but this angle, if this is X, then this angle will also be X. If this angle is a Y, then this angle will also be Y. So these two triangles will be similar. And if they are similar, we can equate the side opposite to them, right? We can say that the sides opposite are in the same ratio. So side opposite to angle Y in the triangle on the left is CD, and opposite to Y on the bigger triangle on the right side is 25 minus X. So CD by 25 minus X, which is dB, is equal to, say we take the side opposite to 90 degree. So on the smaller triangle, the side opposite to 90 is equal to 15. And on the bigger triangle, the side opposite to 90 is equal to 20. So we are using similarity, and we get this relationship CD by 25, and CD value we also know. CD is 12. We just calculated earlier. So this is 12 by 25 minus X. So using this, we can get value of X. 25 minus X equal to 12 into 20 by 15. And this is 4, this is 5, 4, you get 16. So X is equal to 9. So this is equal to 9. This is equal to 16. We could directly have used Pythagorean theorem also. In fact, we didn't need to do all this work. It just didn't strike me, but we could have directly applied Pythagorean theorem. You know, this is 12, this is 20, so this will be 16. This is 12, this is 15, so this will be 9. So you didn't even need to use all this. It was fairly straightforward. But once we get this, now what do we need to do? So we have got the length that we needed, and we had thought what we were planning to do was equate areas, right? We had said that area of, let's say, this triangle ADC, area is equal to half into base into height. So half into 9 into 12, because this base is 9 and this height is 12. So this triangle's area is half into 9 into 12, but that's also equal to in radius, which is R, into S, and S is equal to sum of sides divided by 2. So we sum the sides, 15 plus 9, 24 plus 12, 36 by 2, 18. So from here we get R1. So if we call this R1 will be equal to 54 by 18 or 3. And you can do the same thing for the second triangle. So this triangle's area is half into 12 into 16, half into 12 into 16, and this is equal to R2 into again S, and S would be A plus B plus C by 2, 16, 12 and 20. So 28 plus 2, 48. And you can again simplify. So is it coming out to 40? Sorry, I made some mistake now. So 48 by 2. This will be 48 by 2. So and you can simplify. I think this will come to 8 by 3. So just check if I made some mistake, but otherwise, and then R1 plus R2 is the required length, which is 3 plus 8 by 3. Now there is a formula also to get the in radius of a right angle triangle, etc. But I don't recommend that you remember all that. Doing this will not take you time. Right now it's taking more time because I'm explaining everything. But if you are good at it, if you are an expert, then you would very quickly be able to do all this work. Within like, I would say 2-3 minutes you should be able to solve this. And 2-3 minutes to hote hain exam mein. So it should not be very difficult to do. R2 4 आ रहा है क्या? He's saying R2 is 4. Half into 12 into 16 equal to 16, 12, 28. 16, 12, 28 plus 20, 48 by 2. So just let me check. R2 into 24 होगा ये, and 16 into 4. 16 into 4. So R2 would be, I'll just correct the calculation mistake also if I made any. R2 into 16 equal to R2 into 24, and then you can do this 6 and 6, 4, 4. Yeah, so R2 is equal to 4 actually. So R1 plus R2 will be equal to 7. So it won't require a lot of effort also because you see, if I were doing it in an exam setting, let's see how you would be able to do it quickly. You see this is 15, this is 20. So you directly know that this side is 25. So that I know. I have done questions similar to this. So I know this side I can very easily get 15 into 20 by 25. So that is 4 by 5 into 3. So this becomes 12. That I know. If it didn't strike me right now, but hopefully in the exam I wouldn't be that dumb. And I see this is a right angle triangle. So this is 15, this is 12. So this should be 9, this is 20, this is 12, this is 16. So यहाँ तक तो you should be able to do within seconds. कि I have just marked this. Now I am thinking how can I get in radius? And in radius I know अच्छा इसका area निकल जाएगा, and I know a formula R into S. I know all the three sides. So it should be fairly quick to do. And then you do that R1, R2 वाला thing, which should take like 1 minute max, and you get both these values. And then sum it up. So it should not take a lot of time. If it takes you a lot of time, it's probably because you lack expertise. आप एग्जाम में सोच रहे हो, you are spending time in the exam remembering things or thinking through. Exam is not to think a lot. Specifically if you have already done those things, वो चीजें should be on your fingertips. They should be like एकदम मतलब question देखते ही you know कि अच्छा this one has these kind of things which I can do. These are the formulas which can be applied. These are the relationships which should be there. And these are the kind of questions which I had attempted, and they had these kind of tricks. So ये अगर पूरी list if you have in front of you, then you can do it fairly quickly. Okay. ये वाला question है a bit complicated. If you see it for the first time in the exam, it might be a bit difficult. But now that we are seeing it, hopefully we'll learn something from it, which we can use in other exams. So I think this is a mock question. Some of you might run into it or might have already run into it in a mock or something. So 5 circles, 2 direct common tangent. So this is the way these circles are arranged, and they have a common tangent, 2 direct common tangents. So the tangents will be of this sort, right? So there will be one tangent here and one tangent from here. We did some questions like this, which had direct common tangents and 2 circles in the previous session, and we used similarity related concepts. So itna to anyway you would strike you that probably I need some similarity concepts and to solve this question. What the question says is this radius is 8. So this is 8. R1 is equal to 8. And this one's radius, R2's radius is 16. So we have 8 and we have 16. And we have to find the radius of the circle in between. What will be this what will this radius be? So before we solve this question, we'll do some analysis on 3 circles, and then we'll come back to this one. So let's assume there were only 3 circles back to back. I have the image. I'll try and zoom in on it also a bit so that you can see a bit clearly. So we have 3 circles here, and these are the common tangents. So this is tangent 1 and this is tangent 2. R1, R2 and R3 are the radius for all 3, and we have drawn perpendiculars to the tangent. Now what you need to do is you need to draw a line which is parallel to this tangent. So I have drawn this O1 T2 here, or O2 T3 here. So this is O2, this is T3. So O2 T3. These are all parallel to, if this were say common tangent 1, they are parallel to common tangent 1. So I have made this construction common to this. Why did I make this? Let's look at these 2 triangles, the smaller triangles O2 T2 O1 and O3 T3 O2. This angle is 90. This angle is 90. This is parallel to that, so this angle becomes 90, which is same as this angle becoming 90. And you have done earlier also, if you just extend it, these 2 triangles become similar. So this angle, which is here, will be equal to this angle. So these 2 angles are also equal. Or you can see otherwise also, both these lines are parallel and this is the same line. So this angle will also be equal to this angle. So all 3 angles are same. So these two triangles can be considered to be similar. O1 T2 O2 is similar to triangle O2 T3 O3. If you don't understand, let me know. I'll go a bit slow, or I'll explain a bit more. It's not easy to understand on the first go. So O1 T2 O2 is similar to triangles. So these 2 triangles are similar. These 2 triangles are similar. Now how can I use this? Let's say side opposite to this angle. This side's length is, so this is a rectangle. So this part will be equal to R1. So the part here, the small part, which is T2O2, will be equal to R2 minus R1. And same way T3O3 will be equal to R3 minus R2. So this length is R3 minus R2, this length is R2 minus R1. What is O1 O2? This length is equal to R1 plus R2, and this length is equal to R2 plus R3. And since they are similar triangles, we can say that R2 minus R1. I'll explain, Ashutosh, again why they are similar, but just continue for now and I'll come back and explain it. In fact, I'll revise the whole question again also. Equal to R3 minus R2 and is equal to R1 plus R2 divided by R2 plus R3. Okay, we have got this relation and we'll very shortly simplify this to get a relation which is R2 is equal to under root of R1 R3. We'll simplify it very shortly, but first I'll revise what I just said. So let's see what we are doing here. What we are doing here is we have this tangent, common tangent. We draw a line parallel to the common tangent from O1, which meets at T2, and from O2, which meets at T3. Then look at these 2 triangles. This angle is 90 because it's parallel to the tangent. So if 90 is here, this one will also be 90. Same way, this angle will also be 90. parallel to the tangent. This line is parallel to the tangent, same transversal. So if it is getting 90 over there, this one will also be 90. So one line is already, one angle is already same. Let's look at the other angle. Since this line is parallel to the common tangent and this is also parallel to the common tangent, these two will also be parallel. So the lines joining the center will be cutting these two parallel lines. So the angle they will create with these lines will be the same. So both these angles will be same. So we have got two angles which are same for these two triangles. Third one will also be same, and these two triangles are similar. So we get that these two triangles are similar. Once we got that part, that these two triangles are similar, we're trying to compare sides. We know this side is R1 plus R2 and this side is R2 plus R3, and this length here is R3 minus R2 because this part here becomes R2 and total is R3. So this length becomes R3 minus R2 and this becomes R2 minus R1. So we compare them and we get this particular relationship which you are seeing here. And then you just need to solve for R2. If you solve for R2, maybe you can do it the whole thing also. You just multiply it. You will get R2 square minus R1 R2 minus R1 R3 plus R2 R3. You can use componendo, dividend, etc. to simplify it much more easily. But even if you do the whole thing, minus R2 square plus R2 R3 and minus R1 R2. So these are terms you need to solve for R2 square. I think the other one should get cancelled or something. 2R2 square minus R1 R2 and minus R1 R2. So these get cancelled. R1 R3 goes that side, R2 R3 gets cancelled. So you get 2R2 square equal to 2R1 R3 or R2 equal to root R1 R3. So we have done all this work to arrive at a relationship which is this one, R2 equal to root R1 R3. I do not think you can do this in the exam. You can, but it will be too time taking. So, but now that we know it, we can use this relationship. So what we know is if there are three circles which are adjacent to each other, then the radius of the one in between I'll answer your question, Vikas. The radius that we got in between, the radius of the circle in between will be equal to under root of the first and third. So anytime you face a situation like this and you have 3 here and 8 here, you want to know the radius of the one in between, it will be under root of 3 into 8 or 24. So this is useful that way. Okay. Now let's come back to the question we had. What we were given is, let's see, we were given this question where we have 8 as the radius of this one and 16 as the radius of this one. We need to find this particular radius. How can we do? Let's assume some numbers. Let's assume this is x1, this is y, this is x2. So you know x1 is equal to root of 8y from what we did just now. The one in between is the under root of the ones on the side. Same way, you know y is equal to under root of x1 x2, and then you know x2 is equal to root of 16y. Right? That's fine, right? Yeah. So now we have these three relationships and we have three equations, three variables, x1, x2 and y. So you should be able to solve and get the answer. Let's try what we can do. We can probably substitute x1 and x2 in this one. So we have y equal to under root x1, x2. Let me delete this for now. Y equal to under root x1, x2. So y is equal to under root of root 8y into root 16y. So there is a root inside the root, so don't get very confused. This is y, and this is root 8 into root 16. Let's leave it like that for now. Root 8 into root 16. We'll square both sides. So this side becomes y square equal to y into root 8 into root 16. You can cancel the y. You can cancel the y. And you get y equal to root 16 into 8. And then you can simplify for 8 root 2, I think is there. So how did we do it? One thing we have derived, which now you should probably remember at least some part of the derivation. The exam may, even if you forget the exact formula, you're able to derive it fairly quickly. So what we derived was that the radius of the middle circle is equal to R1 into R3 under root. When three circles are adjacent to each other, three circles are touching each other and they have a common tangent. So this was the condition. They have two common tangents and they are touching each other. Then the radius of the middle one will be equal to this. Once you know this, this question is easy. If you don't know this, this question is almost impossible to solve. So at least now we know, so we should be prepared. अगर नहीं पता होता तो छोड़ देते क्वेश्चन एग्जाम में. It's fine, you can leave 1 or 2 questions and still get through. That's not a problem. But now we know we should always be prepared for such similar questions. If anything comes like that, this is an idea which should come to your mind. Now, from what Vikas is asking, so Vikas's question is, do we have to try all the formulas or concepts we know, or through intuition one can guess which approach to go for? No, Vikas, we don't have to try all the formulas and concepts we know. That's why we practice. The more you practice, the better your intuition would be, because you would have seen similar scenarios in the past. You would know which one works. But if you know all the formulas and concepts, you will have a very good list of prioritization. First I'll try this because due to your practice you know कि इस तरह के question में ये चीज work करती है. If it doesn't work, you'll go to second thing which comes to you. अच्छा ये वाला try करते हैं. Sometimes it might be a combination of one or two things. So knowing all the formulas, concepts really well is extremely critical. Just knowing would not help. In an exam like CAT, it would not help. You don't have time to think. It's not like a board exam कि पता है तो वहाँ पे थोड़ा सा derive कर लिया, थोड़ा time extra मिल गया. Because you have to do 30 questions in 1 hour. So you need to know all of it really like the back of your hand so that you can quickly go through these things. Most of the time, what might happen is that the first intuition that comes to you does not work. So you have to go for the second thing or the third thing. And so if you have a good list in your, not a list, as in if you have a good, if you have practiced very well and you know everything, then those things will come automatically. कि इसमें ये नहीं लग रहा, अच्छा एक और वो चीज भी देखी थी, maybe that one will work here. And that way you would be faster. So those people who are able to do questions faster is because of that reason. So that's, I hope that answers your question. I think this is the final one, I hope, because I wanted to cover some polygon stuff also, but the questions were slightly difficult, so it's taking a bit more time, but it's fine. We have two circles, they're equal and they intersect each other. We are given that the centers do not lie inside the intersection, so the centers are always outside the intersection. What is the smallest range that includes all possible values of this? So this is the situation and we have to find the range for these things. What is the maximum value and what is the minimum value of the sum of these angles? इन दोनों का sum का maximum and minimum क्या होगा? Now, how do we go about it? So here you need to have a bit of a feeling कि the maximum will happen because as these two circles start moving, this circle starts moving closer to each other, these 2 points start moving in this direction, right? And the angle keeps on increasing for both of them. This angle keeps on increasing. The angle will be maximum when this circle actually passes over O. So when this circle reaches this side, and since they are equal, the other one will also be passing over this one, then the angle is maximum. So we can calculate for that. Let's say this is the situation. Now we have reached here. This is C, this is C dash, this is O, this is O dash. So the circle is passing through the center. And now you need to calculate this particular angle. So this is R, this is also R, and we know this is also R, right? And both triangles are equal, so this is also R. So it becomes an equilateral triangle here. So this is 60, this is also 60, this is also 60. Same with this side also, an equilateral triangle will be formed. So this side also becomes 60. So this angle is equal to 120 degree, and same for this angle, which will be equal to 120 degree. So the sum will be 120 plus 120 or equal to 240. So the maximum that this angle can become is 240 when they are almost crossing through the center of the opposite. What is the minimum value that you can get for the sum of those angles? So this is the angle we are talking about, right? This angle, and I'm sorry, my drawing is not great, but this angle. So these two angles. What would be the minimum value? The minimum value will be as this circle starts moving to the other side, this angle starts decreasing, and it becomes almost minuscule when they're just touching, when they're almost like this. Imagine this kind of a scenario. Then these angles are very small, right? They will be just they have become small and they have just touching each other. So they keep coming closer, and when they'll just be touching each other, both these angles will be approaching 0 degree. They will never be 0 degree, but they'll almost be 0 degree. So the range for these, the sum of angles would be between 0 and 240. So the range will be between 0 and 240. Not a very difficult one, but the thinking might be a bit tough. So I covered it here. You all yourself think about it. It will be clear. Also, you practice this question because there are a lot of questions which have a scenario like this. So once you have analyzed such scenarios in different ways, you will be able to solve them quickly. Vikas asking to explain once more the max part. So what I am saying, Vikas, is the angle increases as this circle moves towards this. As their overlap increases, you imagine what will happen. This point will move towards that side. If I am moving this circle this side, this point will move towards this side, and the angle would increase, right? And the angle would keep increasing as it keeps coming in, and the maximum will happen when it exactly crosses over the center. And at that point, this circle would also be crossing the center of the other one because both circles are equal. So it will be a symmetrical figure. So that's what I have drawn here. That this circle is crossing through the center of this particular one, and the other circle is crossing through the center of this one. And then you can calculate the angle, because when you join this is radius is r. This one's radius is also r. So this side will also be r, and this one will also be r, and same towards this. So these are an equilateral triangle, so 60 each, and same equilateral on the other side, so 60 each over here also. Okay, so this becomes 120, this becomes 120, the sum becomes 240. Okay, we have one more. I thought this was the last one, but we have one more which is tricky. Which is fine. It's good practice, and we need to hopefully once you have practiced these questions, revise them twice or thrice, you will become much more confident in circles. So what do we have here? We have 3 circles. Each of them have a radius of 4 centimeter, and we have wound a string very tightly around it. So we need to find the length of the string. So the length of the string would be this particular length, but then it would also be this particular length, and then again this length and this length. So this is the length we need to find. How much would this length be? So what can we do? We know the radius of the circle is 4 centimeter for all of them. Let's join them. So this is 4, this is 4, this is also 4, and same way here, both of these would be 4, and this would be 4. And it's 90 degree. Let's join these sides also. So we have joined these sides. So this is 90 degree, this is 90 degree. This length is equal 4. So this will be a rectangle with this side equal to 4 plus 4, 8. So this length we know is equal to 8. So we have got that this length is equal to 8, because this particular part is a rectangle, because both these are 90 degree and same length. So this will become a rectangle, and hence this becomes 8. So that part we know, but we also need to find this length, right? Because iske bina kaise hoga? And we did it earlier. First session mein circle ke we discussed ki the length of a sector would be 2 pi r into theta by 360. So if the total thing is 360 and if we know this angle, we can get this particular length. Can we know this angle? We can, right? Because the triangle in between is an equilateral triangle. It's all three sides are 8. So this angle we know is 60. And this one is a rectangle. So this angle is 90. Same way this one is also a rectangle. So this angle is also 90. Which means this angle will be 120 degree. And same way they're all symmetrical. So this will also be 120 degree. This will also be 120 degree. So what is this particular length? It is 2 pi r and r is 4. So total 2 pi into 4, 8 pi into 120 by 360 or 8 pi by 3. And we have 3 of these. So this one also becomes 8 pi 120 by 360. And this one also becomes 8 pi 120 by 360. Sorry. And then you can sum all these three, right? So it will become 8 pi 1 by 3, 8 pi by 3, 8 pi by 3. So this becomes 8 pi and plus the 3 sides. So 8, 16, 24. So the length becomes 8 pi plus 24. Okay. You could also have thoda sa physics bhi janna hoga, but otherwise you could also have known that the total sum of angles would be 360. Because this thing is completing a total circle, right? It's completing from this side to that side. So if it is completing a total circle, it has to have covered 360 degrees. तो ये यहाँ 120 हो या यहाँ पे 240 हो या जितना भी हो, 120 also you could have said because it's symmetrical. But even if ये symmetrical नहीं होता, अगर ऐसा भी कुछ होता कि एक बड़ा है एक छोटा है एक ये है एंड इस तरह से, तो भी sum of angles तो वो 360 ही होता, because it has to turn 360 to form a complete figure. तो वो है, बट उसमें आर रेडियसेस डिफरेंट होते तो यू वुड नीड टू नो द रेडियस ऑफ ईच साइड, बट यू नो द एंगल फॉर ईच साइड. बट हियर ऑल्सो इवन विदाउट डूइंग दिस कैलकुलेशन यू कुड हैव सेड कि टोटल एंगल 360 आएगा एंड ये सिमेट्रिकल है तो तीनों 120 आएंगे बिकॉज इट्स कंप्लीटिंग अ फुल सर्कल. ओके, एनी कमेंट्स? डिफिकल्ट, इजी, फास्ट, स्लो? पता है सब, नॉट नीडेड. Because at this point we'll move ahead of circles. I want to cover some component of N-shaped polygon. So that I'll cover for 15-20 minutes. But people who are attending, they need to have the stamina also. If they are tired, then we can do it later. No point covering if you don't follow. Any short trick? This was the short trick which I said. You know that it's a circle, so the total angle will be 360. So you don't calculate the other part. You just do 2 pi r. So or 8 pi you get straight away, and 8, 8, 8 you go just by the triangle. So 8 pi plus 24. Practice yourself. Practice this question yourself. Think why I have done what I have done, and you do it once or twice. Then you will find that this is not very time taking. It's time taking because I'm explaining to you every part of it. But there isn't a short trick won't work, because if I give you a short trick for this one, it won't work on the second question. So what's the point? And you will have a list of 200 formulas to remember, and then you would keep getting confused during the exam. So I'm not personally a great fan of tricks, but this one will not take a lot of time. Move on. We are changing a bit of here. So a regular polygon, the smallest regular polygon is a 3-shaped regular polygon, which is a triangle, which we discussed in a great detail, right? So it has 3 sides. The largest side polygon would be a circle because it has infinite sides. You can see that each of them might be considered a side, and it has infinite sides. And in between you have all these polygons of n shape, like 4 sides, 5 sides, 6 sides. 5 sides will be called pentagon, 6 sides will be called hexagon, and so on and so forth. So there are few relations which you know, there are others which you need not know, but they are there. I am not covering them. If you want, you can read through other videos because they're not very important, I feel. So one is sum of interior angles. So if it's a polygon, we know that a triangle's sum is 180 degree, right? We know a quadrilateral's sum of angles is 360 degree. But what if it's n-shaped shape? What would be the sum of angles? So there the formula is n minus 2 into 180 degrees. एक बार derivation देख लेते हैं, it will be easier to remember. One way to derive is just, let's say if I use this point and I start making triangles, how many triangles will I make? If it's a 5, if it's 5 sides, I'll be able to make 1, 2 and 3 triangles, right? If there are 6 sides, I would have joined one more and I would have been able to make, if it had 6 sides like this and this was not there, I would have joined this here and I would have got 4 triangles. So if it has n sides, you will be able to make n minus 2 triangles with all angles on these parts, and so the number of sum of all those angles would be n minus 2 into 180 degree. Okay. So if you have 5 sided polygon, then the number of the angles, sum of angle will be 180 into 5 minus 2 or 180 into 3, 540. For 6 it becomes 720, for 8 it becomes for 6 it becomes 720, for 7 it becomes 900, and so on, because you just use this formula n minus 2 into 180 degree. So that's the sum of angles of a polygon. What Aditya is saying, NC2 minus n is basically the formula for the number of diagonals, which is the second one. So now if you're asked how many diagonals would there be, what you need to do, and we'll cover PNC, but this much though you might know, if there are n vertices, then we can choose 2 vertices in NC2 and each set of vertices will form a diagonal, but we'll remove the sides because they are not diagonals, right? So we'll remove the n sides and this becomes the number of diagonals. And if you simplify it, you will get this equal to nn minus 3 by 2. I won't recommend learning this formula. Just know that this is how we do it and then do it during the exam itself. Just do NC2 minus n. So you don't need to. Other thing is, a regular polygon is something which has all sides as equal. So like an equilateral triangle, a square, a regular pentagon would be which has all 5 sides equal. So each angle of a regular polygon would be equal to n minus 2. If it's n-shaped polygon, n minus 2 into 180 divided by n. Okay. So what it means is this. Let's see how we'll do. We have a octagon, regular octagon. What would be each side of each angle of a regular octagon? So if it has 8 shapes, the sum of angles would be 8 minus 2, 6 into 180. And it has 8 angles and all angles have to be equal. So we divide by 8 and we get 3, 4, 45, 120, 135 degree. So you can calculate it on the fly. Again, don't learn the formula, learn how it is derived, and it should be able to do it within seconds. This won't take time. What takes time is you spending time thinking of the right solution, which will happen if you don't practice things very well. So let's just, for our purpose, we just do it. If it's a regular triangle or an equilateral triangle, each angle will be equal to 60. If it's a square, each angle will be equal to 90. If it's a pentagon, each angle will be equal to what we discussed just now, 3 into 180 by 5, 3 by 5 into 180, and that comes to I think 108. Just check, you can do it, but I'm just showing this for 6 it becomes 120. So these are some values if you are exposed to, you can remember also. If you don't remember, it's fine, you can do it over there also, but generally when you solve questions, there are a lot of questions on pentagons and hexagons, so you generally get exposed to these numbers a lot, so you can remember that. So and then if you need to know external angle also, you can do it, but we'll come to it through questions. So let's keep it at this. So we know how to find sum of interior angles, we know how to find each interior angle, we also know how to find number of diagonals. Now let's see a few questions to get ourselves more comfortable. What is the area of a regular octagon of side 8 centimeter? So there is an octagon of side 8 centimeter. So all sides are equal. what is the area. How can we calculate? One approach which generally comes easily to mind is this one. You combine it to the center. Now, if you combine all sides, 8 angles will be formed. So this angle will be 360 by 8 or 45 degree. Let's assume this edge is A. So it will be equal for all sides. So this will be also be A. And then you can find A using cosine rule. And then you can get perpendicular, and or you can just use half AB sine 45 to half A square sine 45 to get the area of the triangle, and then you can multiply it by 8. So that's one way. We won't do this, but you can practice it. You should actually try it. So what we are saying is this side is 8, this side is 45. So using cosine rule, you can get value of 8 because you know this side is 8. So 8 is equal to A square plus A square minus 2A square cos 45, or 2A square 1 minus 1 by root 2. So from here you can get value of A, and then when you got value of A, you can use it to form area of this triangle and then multiply it by 8 to get the area of the octagon. But we won't do it that way. That is a common way also. It works very well for hexagon, etc., where you get equilateral triangles, and you should practice it. There is another way which I wanted to show, just so that you can do that kind of stuff if required in other questions also. So if we join this, let's say we join these sides, create this kind of a thing. Sorry. So if this is A and this is A and this is 90 degree, this is 8. So we know A root 2 is equal to 8. So A is equal to 4 root 2. So we know all these lengths are equal to 4 root 2. Sorry. So all these lengths are 4 root 2. So the bigger figure, the outside figure, is a square with each side is equal to 8 plus 4 root 2 plus 4 root 2, or 8 1 plus root 2. So that's the outside square. So the area of the outside square will be 8 1 plus root 2 square. And then if we need the area of the octagon, we'll just take out the area of the triangles. So we'll take out half into 4 root 2 square into 4, right? Because each triangle is half into 4 root 2 square, and there are 4 triangles, and you can do this to get the area fairly easily. So this one you can solve further. There isn't a lot to teach here. 2, and then you get 60 into 232 into 64. So this becomes 64 2 plus 2 root 2, or 128 1 root 2 plus 1. Many places the formula is directly given also. People, I think, spend time learning it also. I don't think it's useful because I don't think they'll ask question which requires directly applying the formula of an octagon given that its length is A. And even if it's required, you can derive fairly quickly. So, but knowing this trick is useful. You can combine these things to simplify things in an octagon, because there will be other questions where this length will be given or something will be given and you need to do such stuff. So that trick is a good one to know. This is a relatively easy question. We have a regular pentagon. So all sides are equal. We have a point O inside, and we are given AOB is an equilateral triangle. So this is also equal. This is an equilateral triangle. And then we need to find angle OEA, or this particular angle. We need to find this particular angle. How can we do it? This was relatively easy. For a pentagon we just learned, but we'll do it again. So n minus 2 into 180. So 3 into 180 is the sum of angles. And since it's a regular one, each angle is 3 by 5 into 180. And so you get each angle will be equal to 108 degree. So each angle is 108. This one is an equilateral triangle. So this angle is 60. This is 60. This is 60. and we know this angle will be equal to 108 minus 60 because the total is 108, so this becomes 48. The trick here is to notice that this particular triangle is also an isosceles triangle because these lengths are equal and this length is equal to this length. So if you notice this triangle also becomes an isosceles triangle. This triangle is an isosceles triangle because these two sides are same, and we know this angle is 48, so we can get x fairly easily. X will be equal to 180 minus 48 divided by 2, or 132 by 2, 64 degrees. Yeah. So this is how we can solve this one. Fairly easy. Khud se you should try. You should not take a lot of time. There are two more questions left which I don't want to cover in a rushed manner. So you guys try it, and if you know the solution, post it later on. I'll cover it in the next class. I'll start the next class with these things. So here the question is, this G divides this length in 5:3 ratio, and it's parallel to this side. So these two are parallel. It's a regular hexagon. So we need to find what is the ratio of AF is to GH. So if this is Y, this is X, we need to find X is to Y. So one question is this one. I'll come to Vikas. Last one I'll come to. Each side of given polygon is parallel to the other. This one I am leaving it here. If you want to attempt. I'll come back to this later on in the next class. In the next class I'll start with this. This Vikas, is this the question you didn't understand how it happened? The question here was that there is a point O inside and it forms an equilateral triangle with OB, and it's a regular pentagon. Okay. Then we were asked, this is point O. Then we were asked what will be the value of this particular thing. Let's call it X. So what we said was, this is an equilateral triangle. So each angle will be equal to 60 degree. This is given in the question. O is not the center of the pentagon. O is just a random point. We also know that for a regular pentagon, each angle is equal to 108. So this is 60. So this becomes 108 minus 60, or 48. So this is 48. Now here is the trick. For a regular pentagon, all sides are equal. So this AE is equal to AB. So these sides are equal. But AB, this triangle was equilateral, right? So this is also equal to this and this. So in the OEA triangle, or this particular triangle, this side and this side will be equal. And hence, you will get 180 minus 48 by 2, or 64. Yeah. Sorry, 64 galat likh diya maine. Isse maybe you got confused. 66. Take 66. Yeah. So we'll stop here. In case you have any doubts, questions, feedback, please send them over. You need to revise all this. Just कहानी सुनने का कोई फायदा नहीं होगा. You guys need to go through this session again, maybe 3 days from now, maybe 1 week from now. Ideally, you should go through them twice because a lot of content is covered, and if you need to know, you can fast forward anything which you know very well, but otherwise you should revise these questions twice, thrice. Rather than doing a lot of new questions, this is more helpful if you revise the same question. Thank you for attending. Next session, Vikas, is probably be on Sunday. I'm planning to keep 2 sessions on 15th of August wala weekend, but otherwise next Sunday we'll have another session. We'll cover some questions regarding exterior angle also, and then we'll cover a lot of quadrilaterals in the next session. So we'll have a lot of questions regarding that. So next session is going to be on quadrilaterals mostly. Thanks for attending.